Hello, Professor Aman.
Hello, good afternoon, sir.
Good afternoon. Good afternoon. This is Sameh talking to you.
Yeah, thank you, yeah.
Hello, Professor Sami,
Yeah,
Dr. Kiro, Dr.
yes,
Inbet.
yes.
Let's just wait for 5 minutes until exactly 12 o'clock.
Yeah, Dr.
Yeah.
Kero is the Dean of School College of Natural Science.
It's our greatest pleasure, Dr. Kiro, to meet you today.
Yeah.
Thank you very much.
Yeah. Immabet is my PhD student. Last time I recommended to join summer meeting.
Okay.
Yeah, this is
Next time definitely you will have a great
hopefully.
chance.
Yeah, next time hopefully. Yes.
Thank you very much for your efforts today.
No problem. Yeah, thank you.
Good morning, everybody. My name is Sami Khaled. I'm very happy to join this meeting today.
Professor Sami, it's a great pleasure to have you with us today.
Thank you.
Is it moving? The slides? Are they moving, Professor Sama?
Let me first thank you very much, Professor Aman. Let me first begin this webinar by shortly introducing Professor Aman Dekepo, who is going to present us today about the phytochemical analysis and anti-proliferative activity of resin of Commiphora africana. Professor Aman is an Ethiopian, holds a PhD in bioorganic chemistry from Ehime University, Japan in 2008, and in natural products chemistry in 2002 from chemistry department Addis Ababa University. He did his master and PSc in 1997 and 1990 respectively in chemistry department at Addis Ababa University in Ethiopia. He is a member of the Chemical Society of Ethiopia, Japanese Society of Applied Entomology and Zoology, Korean Society of Applied Entomology, and Korean Apiculture Society. Professor Aman, at the beginning of his career, joined the John Deere College Medical Sciences in 1990. Then he joined the Ampo University from 2008 to 2012, and in February 2012 he joined the Adama Science and Technology University. He's also worked as a researcher in Andong National University in South Korea from 2017 to 2019. He won a research grant funded by the World Academy of Science, known as TWAS, and 2 research grants by ASTU. Using TWAS research grants, he was able to purchase 5 instruments, and he published more than 90 articles and edited 2 books, Plant Extracts in 2019 and Capsicum in 2020. Currently, he is editing a 3rd book entitled Bioactive Secondary Metabolites from Medicinal Plants in Africa. Thank you, Professor Aman. The floor is yours now.
Thank you very much for nice introduction, Professor Sama. The title of my presentation is Phytochemical Analysis and Anti-Proliferative Activity of Resins of Commiphora africana. I'm very happy to have this chance to present in NAPRECA's webinar. So representing the Ethiopian chapter. So actually this work was one of my PhD student work named Wurkudinku. So this is part of his research, and also this is our ongoing research on Commiphora species. So let me first introduce my university. My university is called Adama Science and Technology University.
I'm sorry to interrupt you. Could you please make it as a display, please? Change to the display mode, please. The PowerPoint.
Is it possible? I don't let me. Okay, now how about now? Okay.
Yes, now it's okay. Thank you very much. Yes.
Okay. So this is Adama Science and Technology University, and this is the main gate. So this is what it looks like. So this Adama Science and Technology University is one of 2 science and technology universities in Ethiopia. So this university is planned to have 8 centers of excellences. These are some of those centers of excellences. One of those centers of excellences is the Institute of Pharmaceutical Science, which I'm affiliated to, and plan to work on natural product chemistry, and also want to have this drug discovery programs in the near future. So now the research park is already going to finish within a few months, and then we'll have a lot of big instruments such as NMR and also HPLC, LCMS. All instruments will be installed in this Institute of Pharmaceutical Science within 1 year period of time. So regarding our plant, our country, Ethiopia is one of the center of medicinal plant. We have about 7,000 species of higher plants. Among them, 12% of them are endemic, and many are used as medicinal plants. Even though the reason for this one is we have a lot of landscape. We have lowlands. We have on the earth one of the most lowest ground found is land is found in Ethiopia. We also have medium land and high land. So this is we also have conducive temperature throughout the year. So we have so many plants for this reason. So among the plants we are interested is on genus Commiphora. One of these is Commiphora graha. and I worked on some of these plant species. Some of the plant species mentioned here, like Commiphora mereha, Commiphora spirocarpa, Commiphora langarina, Commiphora kuha, Commiphora confusa, the Commiphora africana. And some of them were collected from even Kenya, and others are from different parts of Ethiopia, from eastern, southern, and also other parts of Ethiopia. So in this work, there was very low information about these medicinal plants, their biological activities, their chemical composition, although we are the center of these medicinal plants. And additionally, it was estimated that by WHO, about 80% of Ethiopian population, and even French population, 75%, Vietnamese 30%, even Indonesia 40% are populations are dependent on traditional medicines, but still there is problems to work further on this plants. So regarding the economic values, in US, these traditional medicines value of US dollar of 60 billion per year in USA alone. China about 1.8 billion, Australia 1 billion per year. In Ethiopia, we have a lot of medicinal plants which are known economically, starting from ancient time, including spices, myrrh, frankincense, and the gums. These are some of the products that are well known in Ethiopia. That's why we are really interested to work on plants which related to myrrh. So if you just see this slide, we have a company working on these medicinal plants, which is called Natural Gum Processing and Marketing Enterprise, which is responsible for collection, marketing, and also all sorts of activities related to these gums and resins in Ethiopia. So, in this company, from the information published from 1992 to 2008, there are a lot of activities reported here. So as this graph shows, there is increase in trend of volume reported tons from this year from 1990 to 2008. This is an increasement in trend of exported volume, and also the values in Ethiopia where the US dollar was increasing in this period of time. And the major importing countries of these materials are China, United Arab Emirates, Germany, Egypt, and also Venezuela. And these are some of the importers of these materials. Actually, when we see how we keep this, we use this plant this is one of the market which is known Mercato in Ethiopia, in Addis Ababa. So these plants are just displayed here. This we have people are selling and buying in such type of condition where a lot of contamination may be also occur. And so this is 1973. Then when it comes to about in 2014, almost the same situation here. So these are the medicinal plants displayed here. These are how they are there. But now, even though we have a lot of traditional medicinal plants, we are less, we use these plants very low. So because we did not give much attention to this, now the Ethiopian government understood the economic values and also health values of these medicinal plants and give much attention and working hard is in the Ministry of Health is still working hard, and we are preparing pharmacopoeias. One volume was already published, and we are also working hard on publish more pharmacopoeias. And again, we are also trying to collect a lot of databases and so on in these areas, and to use these plants economically and for human health. So among this is, as I already said, Commiphora is one of the genus which is known as the family of Bursaraceae, and this genus is available in eastern Ethiopia, Somalia, and Kenya. And in Ethiopia alone, we have 50 Commiphora species, among which 14, which is 25% of these species, are endemic to Ethiopia. And there are a lot of, we gathered during our project, we gathered a lot of information on these medicinal plants. and they have a lot of medicinal values like this is like religious, cultural uses, and also they have also medicinal values to heal burns, wounds, pain, fractures, obesity, so on and so on, insect repellent, snake repellent, and so on. So these are a lot of information we gathered for this on these plants. Among these, milk is well known. This is really like a king of this comifera, the genus comifera, and this is used for as anti-inflammatory and also cure wounds, ulcers, different diseases like respiratory, gastrointestinal, urinary tract infections, and even also used as treatment for HSCD1 infection. So there are a lot of reports on milk. So this is so this one is the picture that was taken from the company National Gum Marketing, the processing enterprise Ethiopia. So these are the resins, gums, and the resins pictures. These are how this area is including many people, female, women, men, and so on, in collecting, in incisions. Some of them are done using artificial incision by making circles, especially Boswellia species, especially called Boswellia papyrifera. They make incisions and make wounds. Then after a few days, the wound will be hardened, and then they collect. So this business includes a lot of people for this in this work. And so this is how we are still working in this value chain. We have offices in Addis Ababa, and then we have office in Adama in northern part, in Gondar, and Gode is the eastern part. So we have a lot of offices of natural gum marketing processing enterprises working on this business, and we export these plant materials all over the world. So this is a photo shows photos of the live plants. This is better. This is Professor Emias Dagi. He is also known in NAPRECA. So he went to the field trip in the eastern part of Ethiopia called the Bulagari Gode area, Somali region of Ethiopia. So this is the residence of Comifera mireha or mire, and this is also another very important plant called Comifera guidoti, and we have coconuts products like resins we collect from this that is shown on the right in corner of this plant. So these plants are well known for their values in perfume industries, aromatherapy, skincare products like that. So so anyway, there are a lot of information we have. So on mirror and also related products, and so actually even I did my MS and PhD in these plants on Comifera and Boswellia species. So we collect a lot of information from botanical information on these plants, their biological activities. Even we published a book chapter on Springer, just displayed here. So please, if you are interested, try to read this information we published on this Springer book series. So actually, even though this lot of information are there, still we know very little on these plants. So that's why we are really still interested to work further on this genus, this Comifera genus. So these are some of the botanical information we gathered during our field trips in Kenya, in different parts of Ethiopia. So a lot of information are there, their local names, their scientific names identified by botanists in Addis Ababa University, and also even we send them to UK, Kew Botanic Garden. Professor Bolesen identified some of these medicinal plants that are well known for their medicinal values, like for example, Comifera africana, which is really interested for this presentation, is used as head plant, edible, stem, used as utensils, and also there are lots of medicinal values reported in literatures. And Comifera confusa, which was collected from Kenya, was also have a lot of importances like gums, chewing gums, and incense, and so on. So a lot of information are there, but still we know about their medicinal values and their their chemical composition, even though we have such information. So this is the plant materials in the method section. This is the Commiphora africana plant. This is what it looks like. This plant was collected from the southern part called Debluk Borana zone, Oromia region. And this plant is actually gives resins during cold season. It gives fluids, and that fluid will be hardened on the plant material, and then we collect those type of resins. So this plant was deposited in Addis Ababa University, and also we sent it to UK for further identification by Professor Wallace. So regarding the plants extraction, fractionation, so this slide shows how we extracted the plants. So first we ground the resins and then extracted with methanol, dried with sodium sulfate anhydrous, and then we partitioned the extracts, the methanol extract with hexane, chloroform, ethyl acetate, and the butanol, and then we were concentrating. We did the different works such as chemical composition, separation of compounds using column chromatography, then biological activities on the extracts and also on the isolated compounds. So biological assay, for biological assay, actually we did cell toxicity test, evaluation of these extracts such as methanol extract, solvent fraction, isolated compounds against 4 human cancer cell lines called A549 non-small cell lung cancers, A2780 ovarian cancer. Then we also have this pancreatic cancer, the stomach cancer. Well, this cytotoxicity activity was done in South Korea. This that time I was in South Korea. I got chance to submit the extracts for this type of activity testing. And we also checked the IC50 values. It was done in the concentration between 0.1 up to 30 microgram per ml. And this is also this is the resulting discussion section in this phytochemical analysis and anti-proliferative activity of this resins of Africana was here displayed. So regarding the yield, the hexane and the chloroform extract showed highest yield between 40 up to 49%. The remaining ethyl acetate and butanol showed very low yield, as shown here, from 0.09 up to 0.13. That means the plant material contains more of less polar and medium polarity compounds. And then the IC50 values of methanol extract and fractions were done in the cell lines already mentioned. So the methanol extract against A549 showed the highest activity compared with the remaining cell lines. N-hexane extract showed good activity against A549 and A2780. And among the fractions, actually, the chloroform was top, especially against A549 cancer cell lines, which is 2.04. It's also good in other cell lines as well, compared with this standard control topocyte. So because of that, we are really interested to work further on the chloroform and N-hexane fraction to do some isolation using column chromatography and also using biological activities. The compounds will be isolated, and then we did biological activities on the isolated compounds. Isolation and the characterization of compounds from N-hexane fraction. Actually, when we did also chloroform fraction, but the compounds we isolated were all the same. KLC were all the same. So we worked on N-hexane fraction because it has a better resolution when we checked on TLC using NXN ATLAS-73. So the fractions with identical spots were collected further chromatographed repeatedly, and then finally we obtained alpha marine comiferic A. This is 112 milligram, the comiferic B by 59.6 milligram, and some other impure compounds were also isolated from this. So actually, during this time we able to identify fully alpha marine and comiferic A. This comiferic A is a new compound that was reported here for the first time, and the structural illustration of the comiferic B and other compounds are still in progress. Other PhD students are still working on it. So isolation and characterization of the compound comiferic A was obtained. This compound was obtained as white powder. This is also a major compound, and we did LC chromatogram of this. This is the black one. Is a chromatogram of the compound, which shows almost the compound was pure. And actually, this work was also done in South Korea by PhD student. He stayed in Korea for about 4 months, so he did this analysis there. This is the IR spectrum of the isolated compound comiferic A, which shows bands between 2,500 to 3,600 centimeter inverse, which shows compatible with hydrogen bonded OH. And there we have also in the regions 2956 to 2872 centimeter inverse, which shows the presence of pH stretching, and also we have carbon stretching, which showed at around 1690. So this is the proto NMR of comiferic A, which was run at 600 megahertz. So this was also done by collaboration with colleagues in Norway. He's the one who did this NMR. Is really the NMR expert. So he tried to show all information we want to extract from this compound. So as you can see, the compound has proto NMR. So he expanded all regions that are very important. The compounds have olefinic regions, proton signals in oxygenated regions, in aliphatic region. Again, it has methyl groups are there, showed very clearly. And the 30 carbon NMR showed the compound has 30 carbons, which are really indicated by expanding every region. And we did all type of NMR experiments like HSQC, HMBC, H2BC, Aducate 1-1, ROSI NMR spectroscopy was done in Norway. So this is just one example that shows HSQC, HMBC, but expanded. So I have also expanded regions, but just I want to show you how far we go to analyze the structure of this compound. So HSQC, which shows direct correlation between carbon and hydrogen, HMBC between 2-3 bonds correlations between hydrogen and the carbon in the compound, and we did inadequate 1-1, inadequate, all informations were there. So based on those information, this slide shows the HH-COSY and HMBC correlations.
I'm sorry to interrupt you, Professor Aman, but you have 3 minutes to end the presentation, please.
Okay. So this is the structure of the compound, and based on 2D NMR, we illustrated structures. So the structures were done by HMBC, but actually such structure were known before. With Toyota 71721 trials were known and already published, but the information is lacking, especially for carbon 14. So we tried to illustrate the structure using different techniques like VCD. So we used the VCD, vibrational synchronous dichroism. This was done in Norway and also Czech Republic. So these are informations that we did experimentally and also using computer simulations. So based on those information, the structure, this stereochemistry at 40 carbon was illustrated as S configuration. And this also shows the S configuration are really very nice consistency here compared with R. So based on this type of information, the structure of the compound was illustrated. So the activity, IC50 values of activities for comiferic acid as shown, especially at 549, was really high. So this is really interesting compound compared with others. This is the graphical demonstration for this. Anyway, as conclusion, the suspect activity as showed the most sensitive coniferous species A5541 is really interesting for all compounds in the extracts. And this new coniferic acid showed really interesting activity against these cancer cell lines. And this type of compounds are not really common. So we are really interested to work further in this area and to isolate more compounds with similar type of skeleton and to want to make more derivatization to further activities. And we recommend really, we want to collaborate with national, international, and the NAPRECA members to really support us to do further work in these related areas. This is our published article. You can see further on this work. And these are really my collaborators, these PhD students, these are collaborators in different countries worldwide. So thank you very much, Professor Sam.
Thank you very much, Professor Aman, for this very informative and timely presentation, actually. I think we may have a lot of stimulated discussion, a lot of questions, stimulated discussion. So I open the floor for discussion. If anybody of the attendees have any question, please. I may start the presentation, the questions by asking you: did you do any kind of other activity other than cytotoxic activity on the chromophoric A molecule?
Actually, we did antimicrobial activities.
Okay.
But we did not get further. We started working, so we need to get more data which can be publishable. But we did on the extracts and also this comiferic A antimicrobial activity. It showed good activity. But if we finish all studies, all plant compounds from this plant, we want to compile this information together. I want to publish these kinds of works. Thank you. It is a really interesting question.
Great, great. Okay, other questions, please, or comments from the audience? Professor Sami, Professor MG. Yes, please.
Yes, good morning. Thank you, Prof. Aman Dekepo. We have exchanged a number of emails before. I know this guy. Yes, he has very good research output. I'm very impressed by the presentation as well. Just one question that you have a number of species, it seems, in Ethiopia, and that is a great actually presence for this species over there. Have you any sort of differential chemical compounds found between these different species within the same genus?
Yeah, a lot of different. Thank you, Professor Sama. Really, I am appreciating you. I know you also very well. So you are asking really interesting questions. So these plants belong to the same genus. Some of them they have similar type of compound. For example, Commiphora miraha, compound from Commiphora miraha, Commiphora spherocarpa, Commiphora catap. These are really sesquiterpenes, sesquiterpenes. Even sometimes it was confused that sesquiterpenes were previously reported from Commiphora miraha, but finally we also checked those compounds from this plant, Commiphora spherocarpa and Commiphora catap and Commiphora epiguzina, collected from Kenya. So these have related compounds. They have related compounds. But when it comes to other species like Commiphora elangarina, which is also available in Ethiopia, I collected it from Gode region. So they have really different compounds. We didn't find any sesquiterpene. We found those cases chronoaflotoxin type of skeletons, completely different lignans. So those kind of structures were there. When we just see the Commiphora coa, contains triterpenes like mansumbinos, even which lacks like 8 carbon, something like this. So some of the plants contains triterpenes like Commiphora africana. So there are really, even though they belong to the same genus, there are some similarities, some differences. So maybe you have to really sort out why those type of similarity differences happens.
Yes, I'm just was wondering if you have ever thought of doing LCMS, so to profile these different species chemically, and possibly you will find one of important chemotaxonomical marker among these different species, and that will be very good that we see even within one example, we can see if this compound is present there and has such cytotoxicity. Maybe the others, they could have the same compound in them or not. So that was